Hi, previously I designed two discrete compensators to improve the step response of a first-order RC circuit. This time, I went fully analog by using only operational amplifiers, and for that I used the frequency response design method based on body plot. Specifications are kept the same: no steady-state error, a settling time of 2 seconds, and an overshoot that does not exceed 20%. So the chosen structure is an integrator followed by a lead compensator. The first step is to convert the time domain specifications into their equivalent in the frequency domain. Assuming a second-order system, the phase margin can be linked to the damping ratio, whereas the closed-loop bandwidth can be expressed as a function of both of the damping ratio and the natural frequency. The second step is to choose a gain value to satisfy the bandwidth requirement. A good rule of thumb is to set it so that the crossover frequency is half of the desired bandwidth. After some iterations, I went below that by setting the gain for around a third of the desired bandwidth instead of a half. The third step is to compute the value of alpha and tau by using these well-established expressions. The goal here is to counter the decrease in phase margin caused by the increase in crossover frequency introduced in the previous step. To validate my design, I used SPICE-based simulation software. I started by setting all the capacitors to a value of 100 microfarads. Then, by equating transfer function of both of the circuit and the designed controller, I managed to find the value of each resistor. The final step is the implementation on real hardware. For that, I use three LM358 chips powered by a dual power supply of plus and minus 15 volts. The first chip is used as a buffer. The second performs the summing and the integration, while the last one implements the lead compensator. After applying a 1 volt step input, we can see on the oscilloscope that the output of the closed-loop system reaches the desired set point in 2 seconds and does not overshoot more than 20%. Therefore, the set specifications are fully met. I hope that you enjoyed this demonstration, and I thank you for your attention.